Hey everybody, Dr. Heldman here. Welcome back to Tech Talk Education. How the heck are you doing? So in this video, what we're going to do is we're going to begin installing the software that we need for our Linux cluster server environment. And we might even write a little bit of code to verify that it is indeed running. So hang in there. Let's get started. This should be really informative and fun. So on the screen in front of you, you can see that I went back into Canva and lowered the title a little bit. I think it looks okay. I could have even come down another 1/4 of an inch or so, but I'll let it go as it is. So here we are. We're ready to begin trying to exercise this cluster environment. And the first thing we want to do is, of course, run a sudo apt update and a sudo apt upgrade. I'll let you go about doing that. I've already done that in this section here. Now, there's a couple of things we want to think about. We need to install GCC if it's not already running. So let's check on that and see if it's running, and then if it's not, get it installed. GCC stands for the GNU C compiler, and we're going to wind up writing C code for the work that we're going to do on the cluster. So we need to verify that that is indeed present. So to validate that GCC is installed, it's a pretty simple command. It's just GCC, GNU C compiler is what that stands for, tac version. This seems to be a pretty common option now with most of the software. This tac version seems to work like tac help. It's pretty common in all of them. And this says that I do have this installed. Now, what would happen if you did not have it installed? What would you do to be able to get this up and running and going? It's actually pretty simple. So you would just do a sudo apt install GCC tac-y. Go through the process. It doesn't take very long for it to get going. So that's what we have to do in order to get GCC running. I've checked all 3 nodes. Everything looks just fine. I wouldn't be surprised if it's not already installed for you, because GCC is such a popular C++ compiler, things like that. Now, if you were going to write some Python code or something like that, you'd probably have to install Python so that you would have a Python interpreter on the machine. But in this case, we're going to use the C language to do all that. Now, this has to happen on all 3 nodes. So at this juncture, what you want to do is you're going to have to go to master node, check GCC, compute node 1, check GCC, compute node 2, etc. The next step that we're going to do, actually installing the software that we're going to use, is called message passing interface. There are actually 2 versions of it. We're going to install OpenMPI. There is another software product called mpi.h that is not open source, and I think that we're better off using OpenMPI, as it's a little friendlier in what we're trying to do here. You should go out and research mpich. I will put that link in the video for you so that you can go take a look at what's going on there. I'll also put a link up on here in the notes when we're done with this. But what we're going to do now is I'm going to right click and paste the command here, and I want to show you the command. So you understand sudo apt install, that's easy. What we're going to do now is we're going to install OpenMPI bin. MPI stands for Message Passing Interface. We're going to install the bin folder here. Let me click up in here and click something else. We're going to install the common folder, and we're going to install lib or lib OpenMPI tac-dev tac-y. So we need all of these files in order for us to be able to run MPI across these nodes. And again, you'll have to do this on all 3 nodes. So we'll see what this looks like. It doesn't take super long, but it's not the fastest of installations either. So I'll go ahead and put you on pause. I'm going to get my other 2 going, and I'll come back and talk to you once we're done with this. Okay, that's all groovy. We've got that all installed, and I've got it installing on the other nodes. That's one of the great things about VirtualBox copy and paste. You can copy the command in one area, paste it in the other 2, and that saves you a bunch of time. Another thing that we have to do is we have to create a new file here. Now, we only create the file on master node. The other two nodes do not need this, and it's called mpi hosts, plural. And so we're just going to do a nano, and then I'm going to say mpi tac hosts, like that. And what we do here is pretty easy. You type in the IP addresses of each of the machines that you want to use. So in this case, I'm using 1.2 as my master node, and you could hit a tab and say slots equals 2. 192.168.1.3 slots equals 2. What does this slots equal mean? Well, this is a number of processes that you're going to allow for each machine. You could jack it up if you wanted to. Since we're running so light and airy and crisp inside our VMs here, we have to, because we don't have the kind of horsepower that a formal Linux cluster server would have. We jack this down a little bit, but the idea is the same, that we're allotting a certain amount of processors to each of the nodes in order to accomplish a task for us. I'll do a Control O and Enter to save, and a Control X. Okay, and now we're getting into the C code. Now, if you've never written C code before, it's a lot of fun. You should definitely take a C class or buy a C book. There's a guy on the web who is really, really good with this, and his C training is free. And I will try and put that on in the remarks for you so you can go out and watch his YouTubes on C coding. You need to know C coding if you're going to work with MPI. So here we go. Here's what we're going to do. We're going to create our very first MPI code. We're going to call it hello MPI. So I'm going to do a nano hello underscore MPI, and we want to put the .c on there because we're instructing the computer, we're instructing our program here that we're going to be using C code now inside this script. So let's hit enter, and now we're starting in. Now I'm going to look at my notes a little bit because there's a lot of code here, and I'm going to explain the code to you as we go along. So let's get started. So first thing, when you're working with C, a hashtag is a single line comment. And we're going to do, excuse me, that is not a single line comment. I'm very sorry about that. Hashtag is a Python single line comment. In C, a hashtag is what is called an include directive. And what we're doing is we're telling it, I want you to include certain libraries here that I need to use in my work. Now the libraries can come in a couple of ways. Let's talk about that. So there is a library called mpi.h. And what we're doing is the .h stands for header, and this is all of the list of ingredients, the things that the program needs to run and use MPI. So we have to include this. Now you might see, instead of left and right angle brackets, you might see a different way of notating this. This is pretty standard though in C and C++. By the way, once you learn C and you learn things about pointers and dereferencing pointers, the data structures, things like that, it's going to be pretty easy for you to go into C++ and learn C++. I don't mean easy in terms of C++ is like chess. It takes a lifetime to learn. But I do mean that you'll have the basic syntax of the commands. Another one that we're going to include is quite common. It's called standard I/O. So we're going to do an include stdio.h. These are header files. Notice here that everything shows up color-coded. That's a really good thing. We like that a lot because we can tell when we're dealing with an entry like this versus a command like this. While we're talking about this, let me show you the two comments that you can use. You have two types of comments you can use in C code. The first one is a single line comment, and it is // and we'll say that these are include directives. Include directives. And then there's another one that is a block comment, meaning I can have one more line. So it's // and this is a block comment. And you can have as many lines as you want. This is really good for headers. Like you have a header at the top of the program that says, hey, this is the date I wrote it, this is its purpose, I'm the author, etc., etc. So these are what line comments look like in C and in C++ and C# as well. All right, now I'm going to go ahead and erase this because it's taking up a lot of room and I want you to be able to see the screen. And I can't just block it out and erase it because I'm using Nano. It's easy to forget when you get so used to the GUI tools. I'll get rid of this as well. And then let's just go ahead and bring that up. All right, first thing we do is we're going to declare a function called main. Every C program, every C++ program has a function where the code begins to run. That's the starting point for every program, and it's always called main. So we're going to say int main, left and right, left curlies, right curly. This is how you're going to create a function anytime you're working with C or C++ code. Now this is super simple. Of course, it's evolved a long way from here, but this is the basic layout. I'm going to put one more thing in here. So what this is doing is mpi init, we're accepting an argument called argc, we're accepting an argument called argv, and then we have to dereference this. These are pointers. The concept is I've got a piece of memory here and it's holding some data. I've declared a pointer and the pointer is pointing to that data, and I am pointing to a memory address, so it's pointing to the memory address of that data. What happens when I want to get that data out of there to use it? Well, I have to do what's called dereferencing the pointer, and that's what this is right here. So this is an ampersand. This is called a dereference operator. Let's go through the flow here just to make sure you understand it. First of all, we call main function, and we pass in an argc, which is of type integer. We pass in an argv, which is of type char. We dereference argc and argv so that we can use them. Last point I want to make, everything you do in C and C++, if you have a function here, the function has to have a left curly brace and a right curly brace. If you don't have that, the compiler is going to fail on you. So you must have that. Also, when you're typing in C or C++ commands, you must terminate the command with a semicolon. All commands in C and C++ get terminated with a semicolon. Well, why not these include directives? Because they're include directives. They're saying include a library. We don't need a semicolon there. Okay, here we go. Now we're going to declare two variables. The variables are going to be of type integer. There are several data types in C and C++. You're looking at two of them. An integer is any number that doesn't have a decimal component to it, including 0. And then a char is a letter, character, something like this, just a single one. And we're going to declare an integer here, and we're going to, in fact, we're going to declare two of them. We're going to declare one called world size, and then I'm going to put a comma, and we're going to put in another called world rank. What does this mean? So world describes your cluster nodes. Let me put that in here. The term world describes the cluster nodes. I should say the number of cluster nodes. Plus rank. So what it's saying is, if you think about it, master node is the top of the hill, right? Compute node 1 and compute node 2 are peers in this cluster environment. So these things have a ranking, and then the world size in this case is 3. There's 3 nodes involved here. So what we're doing is we're telling MPI the size of our world and the ranking order that these different cluster nodes have. Now we're going to come in here with another couple of MPI functions. So the first one is called MPI underscore com size. Now take a look. You've got to be careful with this. MPI is all caps. That's because it's an acronym, Message Passing Interface. Com is in proper case. Size is in lowercase. You've got to get that right. Otherwise, the compiler's going to throw an error. But it gets a little bit even worse than that. So we put in left and right curlies, semicolon. I really like putting things in, the beginning and the ending and the semicolon, or in the case of the curlies, I put in left and right curlies right away, because if you forget one, the compiler's going to barf, and then you spend time looking for where the problem is at. So if you just terminate these things like this, left and right parentheses, semicolon, you've got that all, and then you just go in and put in the stuff that you need inside the arguments that you need. Now the arguments that we need in here are all caps. So it's mpi com world, like that. And then we're going to put in a dereference to world underscore size. Let's talk about this real quick. mpi com world here is all caps. C and C++ have this notion of what is called a constant. What the constant means is it's immutable, it doesn't change. And so programmers put these in all caps so that we can readily tell, oh, we've got a constant here that we're working with. So what it's doing is it's saying, I've got this constant out here that came from mpi.h, and I've got my world size here that I've come in with. So in my case, my world size is 3. So it's going to take this 3 and put it inside MPI world. It's going to dereference world size and put it in there. And this whole thing is in the nature of a function called MPI com size. I know it's confusing. Once you get into this and you start learning about C and C++, you're like, man, this is really brilliant stuff. Let's add to that. This started way back in the 60s, guys, with these Linux servers. They were running telephony code. They were running post-branch exchange telephone servers, and C was the big language. This is a very, very hot, very good language that has never gone out of style. Yeah, it's complicated. I'm not going to argue that. You have a little ways to go to learn C. I love the language. I've taken some C classes and C++ classes. I really like the language. I think Bjorn Strustrup, the guy that worked at Bell Labs that invented C++ out of C. So it's like he took C code, which was like a little tiny toad on a rock, and turned it into this huge pterodactyl that could fly. I mean, that's the nature of the thing. He put C on steroids and created C++, and that's the baseline of the majority of work that you do today in computers. You're probably interacting with apps that have someone's used C++ to build those. Sometimes Java and JavaScript, of course, but C++ and C are big players. Okay, let's do another one. So we're going to create one called MPI com rank. And this is exactly as you might think. It's the same thing. So we put into MPI com world, comma, and we're going to dereference world rank. And I used the wrong symbol for that. Should be an ampersand. We tie that off and put a semicolon. When you're troubleshooting this, you're getting a compilation error, you want to make sure that you're checking everything is nested correctly. I've got a left curly here. I've got a right curly here. I've got semicolons here. I'm not missing any parentheses. It's very demanding. It's very exact. C isn't kidding around. You have to have everything exactly correct. If you've missed something, you've got to go back and fix that. And when we're done with the movie, what I will do is I will take this code and copy it into the remarks in the movie so that you have it so you can take a look at it. Okay, now we're ready to actually do the hello world work. Now, if you were in C++, you might become used to using a command called cout, but the old command to print something is called printf, print foxtrot. What are we going to print? Well, we're going to print hello from processor. This is so weird. I'm dying to explain this to you. %d. And we're going to say out of %d. And then we do an exclamation point, \n, comma, world rank, comma, world size, right parentheses, semicolon. Okay, now what is this doing? Well, this is very bizarre. So what print is going to do, all printf does is it prints a string out to the screen. So that's easy. And again, a cout in C++, you might be using cout instead of printf. This is an old print command. And this part of it in the double quotes here, this is a string right there. Double quotes here, and I did not end my double quotes, did I? Yeah, I forgot to end my double quotes, so let me go do that. See, this is why I'm really glad that I'm going over this. The double quotes goes right here before the comma, and you can see now that I put it in green. This is the default for strings. All of these compilers, generally speaking, will show you a string that is in the color green. So it's easy to tell when you're looking at a string. Strings are put in double quotes. Do not put single quotes, ticks I call them, around a string inside C. That's not going to work. When I'm using a char here, yeah, then I can use that. Let me show that to you. So I might, oops, let me come out here and I might say example char gets the letter A, like that, semicolon. That would be a char. Python, you can get away with that. Single ticks, double quotes, it doesn't really matter. You can't do that in C and C++. You have to be sure that you know what it is you're using, what type of character data you're using, because if you have a char, single letter, single character, space, whatever, it has to be enclosed in ticks. All of my strings are enclosed in double quotes. So you must remember that. That's going to bring trouble for you at compile time if you don't remember that. Okay, so this much of it is a string here. Now let's talk about a couple of the other pieces here. This is a placeholder. It's placeholding some data. In fact, it's placeholding a decimal. And the decimal that it's holding here is this first guy, world rank. What does that mean? Well, let's go back through the flow here. We said we've got a world size of 3 and a world rank. We put those into integer data. We called mpi.com world and we passed in world size. Then we called mpi.com rank and passed in world rank, size, rank. So it's got those numbers. Then we said, okay, I'm going to print this out. Print out from processor %d, and it's going into my ranking and it's getting my processor. So I've got a bunch of nodes involved. It's reporting back each one of those processor types is what's happening here. And then out of %d, out of world size. So the way to read this is this first % sign is pointing to this variable here, world rank. This second % sign is pointing to this variable here, world size. I hope that makes sense to you. Very common. In fact, C makes use of this in a little different way that we'll see in some more C code later on in another movie, but that's the main concept there. By the way, once you have this basic layout, you can keep the vast majority of this because it's not going to change. So once you have this, I would save it into like Notepad or something like that where you can just pop it right back in. That's going to help you. It's going to act as a template for you so that when you're ready to write new MPI code, you can execute it and you can save yourself some steps by just keying this stuff in, pasting it in, and having it ready to go. Now the other thing we have to do is we have to put on a final function called finalize, semicolon, and then we have our return 0. That, my friends, is our hello MPI C code. We're not done, but we are getting close to being done. Now what I would do if I were you, before I close this out, I would go and make sure that everything's buttoned up. The include directives do not get a semicolon. Int main looks good here. It has a beginning and an ending curly right here and right here. I've got all of my semicolons in place. I've got my parentheses in place. You just want to make sure you're not missing anything. You didn't get fat-fingered here like come up here, and you didn't get fat-fingered and put a $sign in there like I did, like that. That's not going to fly. You just want to make sure everything's buttoned up and looking exactly the way it's supposed to look. Control O and enter to save. Control X to exit. So that's the first process. The first process is that we create the C code and it's living out here. So if I do an ls here, let me click an insertion point here, ls, here is hello mpi.c right here. Now the next thing that we need to do is we need to compile this thing, and we're going to create an executable out of it. Then we have to make the executable have the correct permissions so that it can execute, and then we have to copy it to the other nodes. So it's a four-part deal. We write the code one place, we get the code living here, here it is right here. Then what I have to do is compile this code. I get an executable out of that. I have to make sure that the permissions are correct for the executable so it will run, and then I need to copy it to the other nodes on the cluster. Alright, so here we go. Here's what we're going to do. So we're going to invoke mpi.cc, and I'm going to tell it hello underscore mpi.c is going to be the name of the program that I'm piping in. This is the C program that I'm putting into the system. I want MPI to compile this program for me, and I'm going to do an output. Taco means output. I'm just going to call this hello MPI without putting on the .c. So the C is called the source code, and then we're going to compile it, and we're going to wind up with an executable. Boom, like that. There we go. That worked great. Didn't show you anything. I'm sure there's a verbose switch for this if you needed that, ls. And now you can see here that it shows up in green. This means that it is an executable. It's ready to go. If I do an ls tac l on hello underscore MPI, let's see what it says. It says that the executed bit is set, so that is great. And what I would need to do is I would want to validate that it is that way on the other nodes, just for giggles and hoots. Anyway, I do not need to set this code here, but if I did, I would say sudo chmod hello underscore MPI. I'd just put it as something like 760 or something like that, probably 777. I'd go crazy, which is not a good idea. Anyway, the executable rights are already there, so we're good to go there. Next thing we have to do is we have to copy this thing over to the other nodes. Now I'm going to use secure copy to that. So I'm going to say secure copy to bill at, and I'll just put in my IP address where the other nodes are at. So 1.3, you could put in a name, like you could put in bill at compute node 1, for example. And I forgot to put in the name of the file. So we're going to secure copy hello underscore MPI to bill at compute node 1. And then we could put in, and we should put in, that we wanted to put it in the home folder of compute node 1. So the way that you do that is a colon and then a tilde. And what that's doing is it's saying, I want you to do a secure copy. I want you to take hello MPI, this executable that we created here at compilation time. I want you to go out to compute node 1 and copy this bad boy to the root of compute node 1's home folder. Let's see if this works. Boom. Now what we have to do is say, yes, we want to do that. Well, we did that with SSH, right? Well, yeah, but this is SCP. So this is a different program that's using this. Type yes. Boom. That is a great sign, guys. So that means that it's working great. Let's go out to compute node 1 and see if it made it out there. So I'll find compute node 1 here. I will clear the screen. ls, there is hello MPI. If I do an ls tac l hello underscore MPI, I should see that this bad boy is executable, and it is, so that looks really good. Let's go back to master node. I like that a lot. Clear the screen, up arrow, up arrow. Let's just copy this to compute node 2. Boom. Very good. Let's go look at compute node 2. Clear the screen. ls, there it is. It's all there. Okay, so what we've done now is we've created the C code. We've compiled it. We have gone ahead and secure copied it to the other nodes. And now we can go ahead and execute this code and see if it works. So here's my command to execute it. So you say mpi run. and then you put in fact, I'll clear the screen because it's a little busy, isn't it? mpi run. Then we tell it what our host file is. Remember that we did our host file, we put in all the nodes, and then we tell it that we want to go into ~/mpi tac hosts. So this is saying I've got a host file. This much is saying I've got a host file, and the name of the host file is found in the root of my home directory here, and it's called mpi host. So I am explicitly addressing the location of this file here. And then I want to tell it that the number of processes that I want it to use is space. This is going to be important that you remember there's a space after this. I'm telling it that I want it to do this 6 times, is what I'm saying here. And then what do I want it to run? I want it to run ./hello_mpi. Well, why do I need this / here? Because I'm in the same folder as the location of this hello mpi executable, and so what I'm telling it is you don't have to go search the path. It's right here, run it right here, right local. That's what we're saying here. Okay, let's see if this thing runs. Boom! That is a great sign. What that's telling you now is that this thing is successful. It's running. Yay, we've got MPI running. I hope you enjoyed this movie. If you like this movie, please subscribe to my channel. I'm trying to grow the channel, and please tell others about it. You're welcome to leave a comment. What are we going to do next time? Well, now that we've got this thing working, we're going to go in and do some serious C code. So we're going to go after this in a little bit different fashion and try and put it through its paces to see if we can get it to do some complicated things for us. I've really enjoyed working with you on this video. I hope you had a good time listening to it and tracking with me on that. I'll put copies of this code down in the remarks for the video, and I wish you a very happy day. Talk to you soon. Bye-bye.